everyone, welcome to Modern Application Development Part 2. Now, since this course is going to focus in a large part around JavaScript and its uses, it's useful to spend a little time trying to understand a bit of the history and the origins of JavaScript, right? In particular, why it and how it originated has implications on how it works, right? And it's sort of good to at least understand some of those so that we are prepared for it and we either know how to work around it or you know how to use more modern versions of the language that sort of get around some of those restrictions. Okay, so where did JavaScript originate from, right? So somewhere around 1995, right, or a little bit before that is when Sun Microsystems came up with this programming language called Java, right? And Java was essentially designed in a way that it could be used in order to implement something called applets. What that meant was an applet would be something that would run within a web browser and would allow tremendous interactivity. It would basically allow you to have a full-blown sort of native application running in the browser. Now, what that meant was it had to be sort of defined as something which would run in its own virtual machine, right? In order to minimize the effects of security issues. We don't want some kind of an application that is just downloaded from a web page running on an app, running on anybody's computer, right? Because it could then read their files, it could send sensitive information somewhere else and so on. So Java was created with a lot of restrictions around how it could be used, but it also stood out very clearly from the rest of the web page because you had to sort of define one area in the page where the plugin would run, right? The Java plugin, and the Java applet would run within that area. And within that area, all the interaction would be different from the rest of the page. Even how the cursors looked, what happens when you click on a certain space, all of that would now be handled by the Java applet and not by the web browser at all. Now, that's powerful, but also sort of separates out completely between the browser and the Java applet, right? So, Netscape Navigator, which was one of the most popular browsers at that time and which has eventually evolved into what we now know today as Mozilla Firefox, right, was one of the best browsers at the time, and one of the people working there created a scripting language for Netscape Navigator, right, in 1995. Now, a scripting language, of course, as you know because you're familiar with Python, the primary advantage of it is simplicity, right? It's easy to use a scripting language. You can just sort of get started. You write the language and you run it through the interpreter and you're good to go, okay? And the purpose of this language was primarily to be used as a glue language, meaning that there would be different kinds of Java applets or different kinds of other systems that are being assembled together in a web page. And the primary purpose of this scripting language was to try and bind them together in some ways that enhance their functionality. So it was not really designed too much for coding. And one of the other things, of course, an implication of this is that because HTML is so forgiving, right? I mean, even if you have errors in your HTML, it pretty much just goes through without really complaining. This scripting language also had to be sort of forgiving. If the scripting language would keep bringing your web pages down and crashing, saying, oh, this feature was not available, people would get quite fed up of it and say, look, I don't want this language at all. Can I just have normal web pages? And given the fact that it was primarily designed in order to assist the so-called applets that were being designed in Java, it was called JavaScript, okay, which of course led to trademark complaints and people saying, oh no, you're trying to ride off the popularity of Java. So then there were a couple of other changes in name, but the point is the name JavaScript pretty much stuck to the point where JavaScript today is as well known as Java, right? Even though they have very little in common except for that part of the name, okay? Now, one of the main issues with JavaScript to start with was the fact that because it was created as this glue language and just sort of hastily put together to run in a browser, it was slow and it has limited capabilities. Right? So this part, the glue language, was useful, but there was only so much that you could do. But then somewhere around 2005 is when things really started changing quite dramatically, right? It was partly a sort of an implication of a thought process rather than anything that changed in the language. It was not that the browsers changed or the language changed very dramatically, but some people came up with some ideas on how to use JavaScript in order to enhance certain functionality. And one of the best sort of demonstrations of this was in Google Maps, which came out around that time frame. Similarly, Google also had something called Suggest, which would sort of type in, give you suggestions as you type. And the point about Google Maps was you could pretty much, of course, most of you are probably familiar with Google Maps at this point. You can sort of, scroll around in a map, you can zoom in, zoom out, and it's all very fluid, right? It just sort of shows you the part that you need to see. Now, when you think about it, how do you do that? Because you have a huge amount of data corresponding to the entire map of the Earth, right, at fine detail, but you can't load all of that information into a small device like a mobile phone or even a computer, right? You can't store the entire Earth's maps concrete. So what was done over there was that as you move around on the screen, the browser would keep sending back requests to the server asking for a new piece of data to fill in the blanks that are seen around it. Okay, and this was all done so seamlessly in the background using JavaScript. That was where the power of JavaScript really came out, and this entire process was described by James Garrett in 2005 and was called AJAX, okay, asynchronous JavaScript and XML. And the name also was popular, the entire idea took off, and this made a huge difference to how JavaScript was used in practice. Okay, in some sense it allowed true web applications that could behave a lot like desktop applications. And the primary difference, of course, from a static application is that you would essentially have a much nicer user experience, partly because the system would only load what was required in order to respond to a given interaction with the user rather than loading a new page each and every time. Now, JavaScript has evolved considerably since then. This was sort of the spark that started the fire, but since then it has really caught on and spread. And, obviously at that point, people started noticing deficiencies of the language, and there were a number of attempts to fix certain problems. And we will be looking at much more of this approach, this whole idea of doing things in the background, right, and asynchronously loading material as we move forward. It's one of the main things that makes JavaScript powerful and suitable for the kind of web applications we are talking about. So now, JavaScript had essentially reached a certain level of popularity, which meant that it could not really be just tied down to Netscape, one particular browser or even one particular company, right? So ECMA, the European Computer Manufacturers Association, developed what they call standard number 262, and eventually this came to be called ecmascript, right, ECMA script. That was primarily sort of avoid trademark issues with Java. Nowadays, in fact, you may not even see the ECMA capitalized, you may just see it as ecmascript, right, as an alternative name for JavaScript. Now, in practice, right, this language standard is what is called ecmascript. So we usually talk about ES versions, right? So there is ES4, ES6, ES5, right? ES6 essentially got established in 2015. This was a fairly major change that introduced a lot of new features in JavaScript. But since then, rather than saying ES7 or ES8, they pretty much just have a yearly release pattern, right? Where they say like roughly June or so of every year, there is a new release of certain features, right? Some things are standardized and frozen, saying, okay, this is what we call ES 2020 or ES 2021, okay? Now, the point is, because they have sort of fixed the time when those releases happen, rather than talking about a specific release and saying, okay, does your browser support all of this in the release? They took an approach which is called feature readiness, right? Where there's a technical committee that evaluates all of these features, decides whether they are ready to be implemented. And then you can say, okay, now this is part of the standard, right? And the only question now is, does a given browser actually implement a certain feature or not, okay? So given that ES6 has been around since 2015, right? For the most part in this course, we will be looking at a reasonably advanced form of JavaScript, okay? And we will be looking at, in fact, fairly new versions, probably even things that have come up in ES 2020 or 2021. And part of the reason we can do that is because even if a browser does not support all of this, there are compilers which do an interesting job of basically taking new features and converting them in such a way that they can still be run by older legacy browsers, okay? So in this course, we will try to make maximum use of some of the good features that have been introduced into JavaScript so that we are not sort of stuck with workarounds. Okay. And yeah, so like I said, which version to use becomes a big question. ES6 has most of the features of modern languages, right? It has concepts like modules, it has good variable scoping, it has proper classes implemented, right? At least the syntax for implementing classes is there. Okay. Some of the older browsers may not support all of this. We have a few possible approaches, right? We could just sort of ignore old browsers and ask everyone to upgrade their operating system in their browser. Or in certain cases, which you might have noticed in applications developed using the so-called Electron framework. One example is the so-called VS Code browser, Visual Studio Code from Microsoft, right? VS Code is an excellent example of how an Electron-based app, a web-based app, can basically be made very powerful, right? The entire thing, if you look at it, it's running a Chrome browser in the background, right? But the Chrome browser is not whatever you have installed on your system. It comes packaged with VS Code. So for applications like that are really going to be used, that's a useful, and an acceptable solution, right? But if everyone needs to package a browser along with their software, it probably starts to make the system very heavy, right? And you start running out of RAM, you run into various other issues over there. There is something called a polyfill, right? Which essentially is some way by which there are libraries that emulate newer functionality so that it can still run on an older browser that does not have the same functionality, right? And effectively what a polyfill is doing is related to this concept of what a compiler does, where basically it takes the newer constructs in the language and modifies them so that they can be run on older versions of the JavaScript engines. Okay. In other words, there are a number of different ways that people have found to work around the problems with versions. Okay. And for the most part, because of this, we will be sticking to fairly modern features simply because that makes the language easier to understand and to use. Now, the interesting thing is, a browser is not the only place where you can run JavaScript, right? Somewhere along the line, people realized that the language as such had grown to the point where it had some very nice and powerful features that even made it suitable for developing the backend, which means that you could replace your Python Flask application completely with something written in JavaScript and running on usually what's called the node.js interpreter, right? There is another interpreter called Dino which has some slightly more restrictive features but is also supposed to be more secure, right? So Node.js is probably what you would find as the most popular backend mechanism for JavaScript at this point. It's the main thing to note over there is it means that you are no longer limited only to a browser. There are implications of this. It means that when you are writing code in Node.js, there are certain things like the DOM may not be directly available to you. You are no longer always running in the context of a document, right? So you need to keep that in mind when you are running Node.js applications. So like I said, there are certain implications of the origins of JavaScript, right? And the primary one was that ease of use was given priority over performance, right? Which meant that it may not always have been the fastest language to start with. This is interesting because today, with all the optimizations that people have spent time on, the engines that are present in modern browsers like Chrome are actually very good, right? Which means that now you actually get fairly good performance out of JavaScript. And not only that, JavaScript is even capable of sort of interfacing with the graphic libraries and the graphic processing units that you might have available in your system. Now, one of the biggest issues with JavaScript to start with was this notion that it could fail silently, right? And why would people want to do that? Primarily because, as I mentioned earlier, HTML was forgiving, right? Meaning that it would basically say that, okay, even if there's an error in your HTML source code, you just sort of ignore it and move on. Try your best. The browser should just try its best to display whatever it finds. Now, if JavaScript also does the same thing, it means that debugging becomes very difficult because you first of all don't know if something went wrong. If it did, you don't really have much scope of finding out where it went wrong because the browser is sort of just tolerating everything that it can, right? Nowadays, of course, given the extent of use of JavaScript, this has changed, right? And there are certain things, for example, like the use strict mode, which is not just possible but strongly encouraged when you're writing scripts today, which will allow most of these constructs of JavaScript to at least get flagged at the development phase, right? It might still go through and finally run in sort of best effort basis on a browser, but it would generate a lot more debugging errors that as a developer you would be able to look at and understand with more clarity. Now, the other problem with the JavaScript origins is because it was sort of a quickly put together language, there were a number of places where the language had sort of ambiguous syntax, right? There is this one concept called automatic semicolon insertion, which basically says that you don't really need to terminate each line with a semicolon. The problem is that's a bit vague. It says you don't need to, but there are a couple of instances where you can actually run into problems if you don't properly put in a semicolon. So unlike a language like C, which is very clear that you have to put in a semicolon after every statement, or a language like Python, which says that no, semicolons are irrelevant, they are not even part of the language. If you put them at all, they will just sort of terminate a statement, but you cannot sort of separate statements just using the semicolon. You need the indentation, right? JavaScript sort of says, yeah, you can put semicolons when you want to, but if you don't, then the interpreter will figure out where to put them. Not the best of approaches, and I would strongly recommend that you follow a consistent approach. And in the case of JavaScript, probably the best solution is put a semicolon after every statement, right? That gives clarity. At least there is no chance that there is ambiguity in the code that you type in. There are also a few other problems. For example, object literals and code blocks both use this double bracket notation, right? The bracket notation, right? And there is also this thing about what exactly is a function, right? When you declare a function, is the declaration a statement or is it an expression with a research value, with a return value, right? Why are all these important? Because they can impact how you parse a given JavaScript file, okay? So these ambiguous syntax variants, of course, they are coming down and they are sort of being deprecated and discouraged as we move forward. So when you are learning JavaScript fresh, please try and avoid any sources of ambiguity, right? Be aware of what these possibilities are. There are a number of very useful tools usually called linters, right? And a linter is something which basically goes through your source code and gives you suggestions on how to improve the readability and maintainability of the code. It's a very good idea to get used to using some of those. Now, another implication of the origins of JavaScript is that it has very limited support for input-output, right? Because after all, you are running inside a browser, you don't really have a way by which you can sort of communicate with the user directly, right? The JavaScript language cannot. Yes, you can have forms, you can do something else of that sort, but the language by itself doesn't have a straightforward way to communicate with the user, which means that all errors have to get logged into something else called a console, right? And the developer then needs to look at that, and that console may not be visible directly to an end user. Now, having said all of this, these are sort of the drawbacks of JavaScript. There are a couple of other things which make it very powerful, right? One of them is the close integration with the presentation layer, right? The so-called DOM, the document object model, and the APIs for interacting with the DOM mean that JavaScript has a way by which it can directly manipulate what's seen on a web page, right? And this is immensely powerful. This is what finally leads to the actual use of JavaScript for developing interactive applications. And apart from that, there is this concept of asynchronous processing and the event loop that we will be looking at in a little bit more detail later, right? Asynchronous processing is one of the things that really makes JavaScript powerful and ultimately also led to its use in the backend, right? Because it allows some very neat sort of ways of expressing programs that can be used in different ways. So now comes the question, how do we use JavaScript, right? And since I mentioned that, it was not meant for direct scripting. So it's not like you take a text editor, you write a file, and like, for example, with Python, you would just say Python and the file name and it would run. To start with, at least, there was no interpreter for JavaScript that you could call in that way, right? Nowadays, there is Node.js, but we'll get to that later at some point. We are not really going to spend much time with Node.js. We are interested in the front end. Now, in the context of the front end, what happens is that you need an HTML file that is actually going to load the JavaScript file as a script and execute it, okay? What that means is you actually need some kind of a browser, well, actually a server to serve the files and a browser that can actually open the files and make the requests to get the files. Okay. You also need to embed the JavaScript itself using some kind of the link notation that's there in HTML. Now, the implication of this is, depending on the browser, it may not work if you directly load the file from your file system, right? It may or it may not, but it also depends. It finally comes down to whether or not it has the ability to access the JavaScript file also directly by loading it like a file, right? If it needs to actually make a separate request for that, it's probably not going to do it. Okay. Now, what this means is that for you, who's as a person who's trying to learn JavaScript, you need to sort of figure out what's a good platform that will allow you to do all of this. And in our case, at least for the demonstrations that I'll be using throughout this course, or at least in the beginning parts, we'll be using Replit, right, which hopefully most of you have some familiarity with, right? And what we will do is, Replit has this nice sort of starter code that allows you to basically create the starting HTML, put in a CSS file, and also a script file in JavaScript where you can put in anything that you want. Okay, so we'll essentially be using that as our starting point in order to go through and understand the basic use of JavaScript. Now, like I said, the document object model is one of the things that makes JavaScript useful. It's basically the structure of the document as shown on the browser, right? And it can be manipulated through JS APIs. Not only can you change the text that is inserted or displayed at different parts, you can even change the structure of the document itself. Okay, and this is pretty much one of the most powerful aspects of JavaScript. Now, the DOM also has some ways by which we can interact, right? And there we basically have some kind of input where you can click, or you can have a text box where you enter data. Even just moving the mouse around can be used as interacting with the application. And it also has output where basically it can display text, it can change the color or the style of text, right? Or it can even draw things on the screen, right? HTML5 has this tag called canvas, which basically allows you to draw arbitrary things onto a screen. So now with all of this, I'm going to end this portion over here with just some references, right? There is this website exploringjs.com where there is one of the books that is available over there is what's called JavaScript for Impatient Programmers. Now this is a very good reference, right? It has very detailed reference material. It's focused on the language, which means that you don't really get too many examples of how you can use it for manipulating things on the front end, or the interacting with the DOM is not really covered in this book. But it's a very good reference for the language itself. Okay. Now, the Mozilla Developer Network, this is something that we have seen even in AppDev 1. It has several examples, compatibility hints, and so on, things that sort of give you a lot of different hints on what kind of aspects of JavaScript programs can be used, and also examples of how to use them. There is a very good interactive tutorial called Learn JavaScript Online. The first several chapters of this are free, but the more advanced topics you need to pay for, right? I mean, it's on a paid basis. And apart from this, of course, you pretty much search online, you're likely to come up with a large number of tutorials. So, pay attention to the tutorials. Please be aware that not all of them are of the same high quality, right? Some of them might sort of even encourage certain bad practices in terms of code, primarily driven by the fact that, that's how code used to be written until certain good features came along, right? So you will need to sort of apply your mind and say, okay, is this really the best way to write code, or is this a good reference? These are some that I can think of that are good starting points, but at the end of the day, it comes down to you as the user. You might find some other document or some other tutorial to be more useful for you. Right. Apart from this, there are a few utilities that are worth pointing out. I'd also already mentioned Babel JS, right? It's a compiler that converts the newer versions of JavaScript, newer forms of JavaScript, things that might not be supported in some of the older browsers, into forms that are compatible with older browsers, right? So it's basically a compiler, or in some cases, people might even call it, a transpiler, a translating compiler, right? Basically, what it does is it takes JavaScript as input and produces JavaScript as output. And the idea behind doing this is that the output JavaScript is guaranteed to be something that will run on even an older version of a browser. It does not have like requirements that your browser supports the latest ES 2021 features and so on. Okay, it can be useful. from the point of view of learning, maybe not so much. From the point of view of implementation, very likely yes. Okay. There is this website called jsconsole.com, which basically provides you with an interactive console where you can try out code. But to be frank, every one of you actually has direct access to a console directly in the browser, right? So anything like Chrome, for example, right, it has the so-called developer tools. Once you activate that, it basically brings up a small console where you can type in basic JavaScript statements, right, and see their impact live. Okay. And because Chrome is a browser that sort of keeps fairly up to date with the latest versions of JavaScript and so on, it's actually a good way of testing out most of the features that are going to be supported in any reasonable modern browser. And of course, finally, Replit, right, which I will be using for some of the demos and has good support for basically working with JavaScript applications.